All right, data wranglers, buckle up because today we're diving headfirst into the world of Apache Spark joins. Ever feel like your Spark jobs are taking just way too long?
Yeah,
Yeah, we do. And I think a lot of times it comes down to picking the right join strategy.
you're absolutely right. Joins are really essential in data analysis. They kind of hold all of our insights together, but
Yeah, they're the glue.
they're the glue. Yeah,
But if you pick the wrong glue, what happens? Yes,
disaster.
yeah.
It's a sticky mess, and choosing the wrong join, that can really just bog down performance,
Yeah,
especially when you're dealing with, really, really large data sets.
absolutely. And to kind of navigate this whole world of joins, we've got a great breakdown titled Apache Spark Joins and Optimizing Them. And we're going to be dissecting 5 key join strategies,
Okay.
from like the super speedy to the subtly efficient, so you can squeeze every ounce of performance out of your Spark clusters.
Now, just to be clear, when we talk about a cluster, we're talking about that network of machines Spark uses to process data in parallel, right?
Yep.
Each machine runs an executor,
Right.
which handles a chunk of the workload. So I think it's helpful to kind of visualize how these joins work if you kind of keep that in mind.
Yeah, absolutely. Understanding those core Spark components is like knowing the parts of an engine before you try to, soup it up.
Right.
All right, let's kick things off with the kind of the star of the show, the broadcast hash join. And this is all about using those executors that we were just talking about.
Exactly. I mean, imagine if you need to share a crucial piece of information like a memo to a very large organization. You could make everyone search a massive database to find that information, or you could just, broadcast that information to everyone directly. And that's essentially what a broadcast hash join does.
Got it. So instead of shuffling these giant data sets across the network, which can take forever, we take the smaller data set and just poof, replicate it on every single executor node.
Exactly. So then when Spark needs to match those data points, it's all right there. On each machine, no more data traffic jams.
No waiting around.
Exactly.
The article has a great example of this using customer orders and product information.
Right.
So let's say we want to enrich each order with those product details, like the
Mhm.
name, price, that sort of thing.
Yeah.
Now, the standard approach, shuffle hash join, that would involve moving both data sets around, even if that product info table is tiny.
Right. But with the broadcast hash join, we can just avoid all that unnecessary shuffling. And each executor gets a copy of that product table, which makes the join operation super fast.
Yeah. Looking at the code snippets, it's incredibly simple to actually implement this.
Yeah.
It's just a single broadcast function call
Yeah.
when defining the join. And Spark does the rest.
Yeah, super easy.
Easy peasy, right?
But there is a catch. Keep in mind that, we are replicating that smaller data set on every executor.
Right.
So it has to be, small enough to fit in the machine's memory.
Yeah.
You can't broadcast a data set that's, massive.
Right. So the key takeaway here is to be mindful of that data size. If one is significantly smaller, broadcast hash join is your best friend.
Mm-hmm.
But what about situations where both are massive? Is broadcast hash join off the table then?
Well, that's a great question. While broadcast hash joins, they're great for smaller data sets, they're not always the best fit when you have two really large data sets. And that's where our next join strategy comes in, the shuffle hash join.
Oh, yeah, the shuffle hash join. It's like the default, right?
Yeah, the default.
It's like taking the standard route even when a shortcut exists. But just because it's the default doesn't mean it's always the most efficient.
Right. And especially when you're dealing with larger data sets, it can be a problem. Remember how broadcast hash joins avoid shuffling by replicating the smaller data set?
Right.
Well, with shuffle hash joins, we don't have that luxury. Both data sets need to be shuffled to find those matches.
Okay.
So it's like trying to organize a library by like scattering all the books on the floor
Oh, geez.
and then trying to find matching pairs.
I can see how that could lead to some problems. The article mentions joining 2 large tables of user activity data as a good example.
Yeah, that's a great example because those tables can get really massive.
Yeah, absolutely. And when you start shuffling that much data, things can definitely slow down.
Yeah.
You mentioned earlier how Spark determines those shuffle partitions.
Right.
Can you go into more detail about that?
Yeah, so basically, think of it like dividing the data into smaller chunks before sending it across the network.
Okay.
Right. And so the number of these shuffle partitions directly impacts how efficiently data is distributed and processed.
So the number of those partitions is really important.
Really important.
Okay.
And this is where things can get a bit tricky. If you have what's called skewed data, meaning certain values in the join key are way more frequent than others,
Okay.
you might end up with some partitions that have way too much data
Oh, no.
and others that are practically empty. And that can lead to big bottlenecks because some executors are just like swamped and others are sitting there doing nothing.
Data skewness.
Yeah.
The silent performance killer.
Yeah, exactly.
So are we doomed to suffer these slowdowns every time we have to deal with large data sets?
Not necessarily, not necessarily. There are some things that we can do. The article talks about some optimization techniques. One approach is to simply increase the number of shuffle partitions.
Okay.
So think of it like adding more lanes to the data highway
Oh, I like that.
to help ease the congestion.
More lanes, more flow. All right, what else can we do?
Well, another powerful technique is to focus on data locality.
Okay.
And that means making sure that related data is, physically stored near each other.
Right, so you minimize that movement.
Minimize the amount of data that needs to be shuffled. It's like strategically arranging a library. So related topics are all grouped together.
Got it. So by optimizing that data locality, we're giving Spark a bit of a head start.
Exactly.
We're organizing things a little bit.
A little bit.
Makes its job easier. Okay, cool. So now, while those shuffle hash joins are often unavoidable when you're dealing with larger data sets,
Right.
understanding those optimization techniques can really reduce their impact.
For sure.
Okay, great. Well, let's move on to a join strategy that brings a bit more elegance to the table.
Okay.
The sort merge join.
Yes.
Sort merge join. That just sounds a lot more orderly than shuffle.
It does, doesn't it?
What's so special about this one?
All right, so imagine you have two lines of people, and each line is perfectly sorted by height, shortest to tallest.
Okay, yeah.
And let's say you want to pair them up based on matching heights.
All right, yeah, I can see where this is going.
So we just walk along those lines at the same time, matching people as we go. No need to search, no need to shuffle anyone around.
So simple.
So simple. And that's exactly how a sort merge join works in Spark.
Wow.
You first sort both data sets based on the join key. And then Spark simply merges those pre-sorted data sets, finding the matching rows with remarkable efficiency.
It's just leveraging that structure of the data to
Exactly.
really streamline things.
Exactly. And the article gives a great example using customer transactions sorted by time.
Oh, perfect, yeah.
So let's say we have two large data sets of customer transactions, and they're both already sorted by transaction time, which, happens naturally in many real-world situations. And we want to join them based on, say, a transactioned column.
Right, so instead of shuffling all over the place like a shuffle hash join,
Yeah.
we can just take advantage of the fact that they're already sorted by time.
Yeah, exactly. And a sort merge join is perfect for this. The article actually shows a code snippet. It's very simple. You just apply the sort function to both data frames before joining them.
Okay.
And Spark handles the rest. In fact, Spark is often smart enough to recognize this pre-sorted structure, and it will automatically choose a sort merge join without you even having to tell it to.
So it's like Spark is learning as it goes, right?
Yeah. It is, yeah. Spark can be quite intuitive, especially when we kind of give it some hints by, pre-sorting the data.
I like it, so we can make some of those decisions for us. But can we always rely on Spark to make those smart choices, or are there times when we need to, kind of give it a nudge?
That's a great point, because while Spark's optimizer is pretty smart, there are definitely situations where we might want to guide it a little bit.
Yeah.
And that brings us to two really powerful techniques that give us a lot more control over how Spark organizes and processes our data: repartitioning and bucketing.
Ooh. Repartitioning and bucketing. Let's start with repartitioning. What's that all about?
Repartitioning, it sounds a bit like rearranging the furniture, right? To make a room more functional.
Yeah. Yeah, is that a good way to think about it?
It is, actually. Remember how we talked about partitions as like smaller chunks of data that Spark distributes?
Right.
Well, repartitioning lets us change the number of those partitions.
So it's like deciding how we want to divide up the data before we even give it to Spark.
Yeah, exactly.
Okay. And what are the benefits of doing that? Why would we want to rearrange things?
Well, the article talks about three key scenarios where repartitioning is really useful. The first one is it can boost parallelism.
Okay.
So by increasing the number of partitions, you're essentially giving Spark more pieces to work with at the same time.
Right.
So if you have enough executor nodes available, that can really speed up processing. It's like, giving a bunch of construction workers more tools so they can work simultaneously.
I got it. Yeah. It's maximizing those resources.
Exactly.
So what's the second scenario?
The second scenario is reducing shuffle.
Oh, okay.
You'll remember our nemesis from the shuffle hash join?
Right, right.
Well, repartitioning on the join key before performing the join can sometimes help us avoid that shuffling during the join operation.
So it's like, again, we're kind of prepping things a little bit. We're giving Spark a roadmap.
Exactly.
So it doesn't have to scramble as much.
Exactly.
What's the third benefit?
The third benefit is balancing data. So repartitioning can help us make sure that our data is spread evenly across those partitions. So we don't have one executor, with a ton of work and another one that's just sitting there. It's about, making sure each worker has a fair share of the workload.
That makes sense. The article had a good example about repartitioning being really useful when you're dealing with that customer data frame that's unevenly distributed.
Right, right.
And I imagine that happens a lot in real world situations.
It does. It does. And so you can imagine, if some partitions are just, jammed with data and others are practically empty,
Yeah.
that leads to inefficient joins, right? Because some executors are just working overtime and others aren't doing much at all.
Yeah, it's not balanced. So repartitioning can help even all that out.
Exactly, exactly. And the code snippets show how easy it is. We use the repartition function, and we can repartition by a specific column, like customer id, or just by a fixed number of partitions.
Simple. But is there a downside to this?
Well, we do have to be a little careful because under the hood, repartitioning does involve shuffling data.
Oh, okay.
Right, to achieve that redistribution.
Yeah.
And so if you overuse it, it can be an expensive operation.
It's like any tool, right? Too much of a good thing can be bad.
Exactly, exactly. Use it strategically, not just because you can.
Good advice, good advice. Now, we can't wrap up without talking about our last technique here, bucketing. That sounds like, organizing a library, right?
Yes.
By genre to find a book quicker. How does that apply here?
That's a great analogy. Bucketing is all about pre-sorting data within each partition based on a specific column.
Okay.
So it's like an extra layer of organization within those data chunks.
Oh, so we're going even deeper. It's like
Mhm.
within the partition itself, we're getting organized.
Yeah.
So it sounds like this would be really useful for operations like filtering or, aggregation,
Exactly.
where you're trying to find very specific data.
Right.
The article used a great example, website logs, where you need to do analysis based on user ID.
Yeah.
Tell me more about that.
So imagine a huge data set of website logs with, details about user activity. And we're always running queries to try to, analyze behavior for specific users. Without bucketing, Spark would have to scan that entire data set every time, right?
Right, right.
To find the data for a specific user would be, really inefficient.
Yeah, it would take forever. Yeah.
But with bucketing, we can pre-sort that data within each partition
Okay.
based on user ID. So when we want to find data for, say, user ID 123, Spark knows exactly which bucket to look in.
It's like we have this little shortcut.
Right.
It tells us right where to go.
Exactly.
More scanning the whole thing.
We're scanning exactly.
Hmm.
And the code snippets show you how to do it. When writing the data, we use the bucket by function, and you specify the number of buckets and the column to bucket by.
Okay.
And then when you read that data back, Spark automatically leverages that structure for much faster processing.
I love it. So bucketing, another great tool.
Yeah.
So it seems like we've covered a lot of ground here on Apache Spark joins. From the broadcast hash join to bucketing, we've talked about a lot of different ways that we can optimize our Spark workflows.
A lot of different ways.
Yeah. What are some of the key takeaways that you want our listeners to walk away with?
Well, I think, the most important thing is that choosing the right join strategy is really, really crucial. It's not one size fits all.
Right.
You have to really consider the size of your data, how it's structured, what you're trying to do.
Yeah. It's knowing the tools and then using the right one.
At the right time.
Exactly. Exactly. And don't be afraid to experiment. Try different join strategies and see what works best for you.
Yeah. Get in there, play around. You might be surprised by what you find.
You might be, yeah.
Well, folks, that brings us to the end of our deep dive into Apache Spark joins. Hopefully you found this episode insightful, helpful, and maybe even a little fun.
I did. It's always fun to explore these topics. Until next time, keep those Spark clusters humming and choose your joins wisely.
And to our listeners, thanks for joining us. Catch you on the next episode. 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 Stepsode, 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 stepsode,